Hello and welcome. In this video, we're going to look at how to use the product rule. The product rule is a method to help us differentiate when we are differentiating a problem that has two parts that are multiplied by one another. So say we have a part here in brackets and that's multiplied by something here in brackets. Since we're multiplying two parts, we will use the product rule to find the derivative. And that makes sense because in math, product means the solution of a multiplication problem. So we're going to use the product rule to find the derivative of a function where we have two parts that are multiplied. So how do we do this? Well, we're going to use the formula. So you will need to know this formula to help you differentiate using the product rule. This formula can be written a few different ways, but I like to write it like this. So we have dy dx, meaning the derivative. So the derivative is equal to u times dv dx plus v times du dx. Now this rule might look very confusing right now, but once you see it used in an example, it will actually be quite simple. So let's look at that example. Let's say we have the function y is equal to 2x squared plus 6, and then we have another bracket, so this part of the function times this part, which is 2x cubed plus 1. Now with this rule, you might be looking at it and thinking, what is u and what is v? Because there's v and u in this formula. Well, when we get our problem, we set u and v to be each one of the brackets or each one of the terms that are being multiplied. So in this case, we could have u be this and v be this. So u is this entire part of the function and v is this entire part of the function. So u is equal to 2x squared plus 6 and v is equal to 2x cubed plus 1. So we already have two parts of our formula. We have u and we have v. Now all we have to get is dv dx and du dx, and we can just sub our values in and simplify. So now let's get dv dx and du dx. So first of all, what is, say, du dx? Well, du dx is the derivative of this equation here where we have u. So we're finding the derivative of this. So we have du dx is equal to, and we find the derivative of this. So 2x squared, this is just using the power rule to find the derivative as normal, so we bring the 2 out the front. That becomes 4x, and we subtract 1 from the power to give us 1, and 6 is dropped off. And then we do the same for dv dx, and that will become 6x squared. Now we have found every value in this formula. We have found u, we have found v, we have found du dx, and we have found dv dx. So we can now substitute these values in. So step 1 of using the product rule is to find these values. Once we have them, we just substitute in. So we get dy dx is equal to, so we have u is 2x squared plus 6. And that's multiplied by dv dx, which is here, that's 6x squared. So I'll just write it like that. We have 6x squared times our u. And then we add, because we have a plus here, and we have v. v is 2x cubed plus 1. And that's multiplied by du dx, which is 4x. And now we have our derivative. It's this, but we want to simplify this. So let's expand these brackets. So 6x squared times 2x squared is 12x to the power of 4. And we'll continue working across, and once we do that, we will get 36x squared plus 8x to the power of 4 plus 4. And finally, for our last step, let's just collect like terms, giving us 12x to the power of 4 plus 8x to the power of 4, which will give us 20x to the power of 4 plus 36x squared plus 4x. So we just solved and simplified this problem using the product rule. And remember, the product rule is when we have a function where we have two parts that are multiplied by each other. And we use the product rule when we are multiplying to find the derivative. Now, this was quite an easy example, and I wanted to start with an easy one just so you can get the hang of it. let's look at one more example. However, this next one's going to be quite a step up, but if you can get this next one, you will be well on your way to mastering this. So let's try a hard example. Now for this problem, we have y is equal to 3x to the power of 1/2 times 2x plus 1. So this is also the product rule. Although we don't have two brackets times each other, we have this term here times by this term here. So there's little times there, and we could easily put brackets around that. It's the same idea. We're still having two parts of our function which are multiplied by each other, meaning we use the product rule. So we follow the same process here. We get u, v, dv, dx, and du, dx. So first of all, let's label this part of our function u, and this part of our function v. That means that du, dx will be equal to 1/2 times 3, which is 3 over 2, x to the power of negative 1/2. And dv, dx is equal to 2. Now that we got all of our values, it's just a matter of substituting them into this equation up here and simplifying. We have dy dx is equal to u, which is 3x to the power of 1/2, times dv dx, which is 2, plus v, which is 2x plus 1, times du dx, which is 3 on 2, x to the negative 1/2. Now that we got our problem out here, we just have to simplify it. So if we look at this, that's the same as 6x to the 1/2 plus, and now we multiply 3 over 2 x to the power of negative 1/2 by both 2x and 1. So if we multiply it by 2x first, that gives us 6x over 2x to the 1/2. Now I'm putting that x to the 1/2 down here so that it can be a positive indice, as when it's up the top, it's currently negative 1/2. So by moving that down the bottom, we get it to positive 1/2, which is a little nicer. And now we multiply that by 1. And anything times 1 is just itself, but when we rewrite this, I'm going to rewrite it 3 on 2 x to the 1/2. Moving the x to the negative 1/2 to the bottom so that it can be x to the positive 1/2. And if we continue simplifying this, we get 6x to the 1/2. So here we can see 6 goes into 2 3 times. And here we have our rule where we have the same base, and we subtract it from what the power is down here. So we have 1 minus 1/2, which is just a half. So we have 3x to the power of 1/2 plus 3 over 2x to the 1/2. And for our final step of simplifying, we have two bases that are the same here to the same power, so we can just add the coefficients. So 6 plus 3 is 9, and the rest stays the same, so we have x to the power of 1/2. And finally we have 3 over 2 x to the 1/2. And there's a few ways you could write that, but let's just write it as 3 over 2 x to the negative 1/2. And that's our answer, fully simplified. Now that problem was a lot harder than the last one due to some of these tricky indices and fractions we had to deal with. And that brings me up to my final point. When you're using the product rule itself is not that hard. You can often use this formula, but the simplifying that goes on afterwards is often quite tricky. So sometimes the hardest part of the product rule is actually the simplifying afterwards. And to get better at that, that's just a matter of getting better at your algebra and dealing with fractions and cleaning up some messy problems such as this one. That will do it for this video. I hope you found it helpful, and I hope you understood everything and could get through it, because this stuff can be tricky. But if you did, good job, and thanks for watching. Please consider liking and subscribing, and see you next time.